Well, is anybody there? Is Twitch working? Let me know. And then when my tea is done, we'll start. Where's the ox? I don't have an ox. I'm not Jeff Minter. I don't know why you would expect me to have an ox. That's all I have to say about that. Test the eye tracker, make sure it's still working. Looks like it's working. Y'all still seeing the eye tracker? How big is the big refactor? We don't know because it's going to be big. It's going to be big. What device software am I using for the tracker? This is a Tobii 4C, or however you pronounce that company's name. And they just give you a streaming plugin. They have it downloadable on their site. So I'm using that to draw the little tracking dot. I don't know if this is the best eye tracker. I haven't even looked to see if there are any alternatives. So if anybody knows of a better eye tracker that you would like me to experiment with, then I could also try that out sometime. I'm going to really move this so that the stand can be far away. Mic stand. Any pre-stream questions? Anything people would like to know? Programming topics generally, but it doesn't have to do with exactly the compiler topic. We'll do that for 3 or 4 minutes. Nope. Wrong focus. Pre-stream Q&A. Questions? The eye tracker is not useful to me, but the idea is, if I'm looking at a bunch of code somewhere and trying to figure things out, you can at least generally tell if I'm sort of looking at the bottom of the screen or looking at the top of the screen or on the right, so you can sort of see what I'm thinking about without me having to gesticulate so much and then forget to do that and forget to clue people in. So hopefully it helps. Thoughts on Godot engine? I do not know anything about it. Will our next game be written in this language? Depends on how you define next game, but we are making a game in this that will be commercially released, yes. There's a Steel Series eye tracker also. Okay. I'd be interested to hear comparative opinions about quality. Quick opinion of GDPR. I don't know, man. Yesterday and today's streams were just about debugging. They weren't any real big topic, but this next one is sort of a bigger topic, so it'll be more coherent. Wouldn't it have been simpler to be a simpler language like C? Yes, it would, but a wooden cart is simpler than a Tesla Roadster, but a Tesla Roadster will get you more places faster and is more ergonomic for daily use, right? There's trade-offs to everything. It's simpler to program in assembly language, but it's not the most productive thing. What should you expect if you want to work in the industry in the future? I don't know. It depends. That's a very general question. You would have to tell me what you actually want to do in said industry. What kind of work do you want to do? Thoughts on using S expressions as a human readable definition data format? No. No. See that I'm not normally going for the data-driven programming approach in my game. Am I opposed to it, or is it not comfortable for me? What do you mean by data-driven programming? You'll have to give me a specific example of what constitutes data-driven programming. It sounds like something I wouldn't like, yes, but I don't exactly know what you mean, so I can't say. Do I have a Tesla? Yes, I do. I have a Tesla Roadster. That's why I thought of that. It's a really good car, although it's a little old at this point. The problem is it can't use the superchargers because it's pre-supercharger. So it does have a quite big battery now because I got a replacement battery for it. But, if you use up that battery, then charging is going to be slow. Is there any possibility to inspect assembly output? Not right now. I mean, obviously you could disassemble the executable, right? But apart from that, not right now, but I would like to do something like that later on because I think you want to know what your program's doing, at all levels. And so once we get done with the language features, I think more introspection into what's happening is going to be a very useful thing. Yeah. What do I think of whiteboard interview questions? I don't really like that method of interviewing. The kind that I like is the mock interview that Casey Muratori did with Sean McGrath. It's on YouTube. Somebody can maybe link you that. That's a good example of how I think technical job interviews should go. Now, it's not a flaw in it. It's actually something strong about that technique, but it requires the interviewer to be technically competent as well, which is why some places may not want to do it because... yeah, anyway, but yes, so check that out. You would like to specialize in computation and work for Intel or AMD. So I don't know that much about what Intel or AMD look for in programmers. So it's really, what I do is very different from what they do. So I can't tell you anything about that, unfortunately. What about inline assembly, inline LLVM-IR? We will not do inline LLVM-IR because LLVM is not our only backend, and we're hoping to eventually remove it from the compiler, except, maybe as an optional way of targeting new platforms that don't support the full compiler yet, right? But inline assembly is in the roadmap. It's just further in the future than we are here today. Have I looked at DirectX 12? I have not looked at DirectX 12, so I have no opinion. You confuse the terms. You mean data-oriented design? It doesn't look like I am doing the tight loops usually seen in code during Acton's presentation. That is true. I am not usually doing those tight loops, but that is because there's a few reasons, but the biggest reason is that, well, first of all, the particular game that we're making is not a high performance game, right? It's a Sokoban game where some people run around on a map. So because we're building a whole engine from scratch, I'm taking the route of making things easier to program rather than making them fastest to program, right? And those are trade-offs. But also, you don't do that stuff first necessarily, right? What you want to do is you want to implement enough that you have an idea what is going to be slow and what is not. And then you use that kind of technique on the things that need to be fast, which, there's a few places that you tend to know are going to need that approach, like we're feeding stuff to the GPU. Okay, well, you probably need to do that as fast as possible, right? Apart from basic stuff like that, you don't necessarily know in advance what really needs to be fast. So let me put it this way. The thing that Mike Acton always says is like, look, if you want to solve your problem, you have to understand your data, right? If you understand the data, then you can program efficient transformations on that data. But if the game isn't very far in development, you don't really understand your data yet. You don't have the actual levels that you're going to have. You don't know how many entities are going to be in the levels. You don't know what types of entities there are, right? So the stage that this game is still in, it's in the stage of development where we're figuring out everything about the game, right? Once we figure that out, then we'll know what our data is, and then we can make efficient transformations on the data. So part of the reason you're seeing that is that it's just early in development. Now, that said, there is a thing that you can do, which is that you can accidentally paint yourself into a corner where I made so many assumptions, like I programmed so object-oriented, for example, that now it would be so much work to change my stuff into tight loops that I'd essentially be rewriting the whole program, and I can't do that, so we have to ship a slow game. That's what a lot of people end up doing. But you can avoid that. There's a fine art, and it probably just requires a lot of experience to know how to do this, but there's a fine art to know how to build things that are easily swappable in that way, right? So that you're not so buried in layers and layers of nested assumptions. So when I build things, I'm always thinking about, okay, what's the probability I'm going to need to make this fast? And if I make it fast, what do I need to do? And how do I do my current implementation in such a way as to leave the minimal number of roadblocks toward that fast implementation later? So that's all. Do I think remaking popular games is a good way to learn game development? Maybe. Like if you like the game and if it's small and tractable, doing something small and tractable is probably the most useful and efficient thing. I don't think my mic needs to be up that high. Yeah. Making Halo is probably not the best first project. I support that idea. Can I move my mic? Oh yeah, this mic arm really goes far out. Oh yeah, we're like a professional streamer now here. All right. The only problem is this stupid stand that this thing. This might, well, I don't want to mess with it. Okay. Okay, people. Let's do the big refactor. Let's do the big refactor. So today's topic is the following. It's a programming language, as you know, and one of the things we do in a programming language is we parse the text into a syntax tree. The syntax tree has nodes for all the different kinds of things, every language construct. And those nodes have different like type stamps. So here's a bunch of different stamps, right? So forth. And each of these enums is also associated with a data structure. So in this file, like, well, if there's an expression, that's sort of the subclass of all this when we don't know much about what exactly the expression is. But then, okay, well, a block is an expression that contains a sequence of statements and some members for declarations, and maybe there's some destructs, you know, and an identifier just has a name and some things, right? Now a procedure is called a lambda here. Lambda is the snooty functional programmer version name for procedure. So it's one syllable less, which is maybe why I still use it. I don't know. I've wanted to go through and name everything procedure. So lambda right now is a big data structure with a lot of stuff. Now, here's the thing. This language has, let's go back to this that we were looking at earlier. This language has no header files like C or C++, and more specifically than that, there's no required order of compilation for your programs. You can declare things in any order. If you cut something out of one place in a file and paste it somewhere else in the file, it doesn't matter, right? Your program's not going to break because you did that. That's very convenient for the programmer, but it means that the system has to do a lot of work to make that happen. And when I first started programming the compiler, you know, I was figuring it out. Like, how do we make all this work well? And, you know, so I made some system where these, you know, different, the relatively serious nodes in that syntax tree, like if something is a procedure or a struct or something like that, they get sort of, you know, queued up in this scheduler that lets their types get inferred independently of each other, and they can, you know, pause and come back later when more information is available to further infer the type. Because if you're going to infer the type for this whole procedure, this is a lot of stuff. You need to know the type of everything in here, right? And those can depend on things external to the procedure and so forth. And some of those things might not even be loaded yet, right? Because it's a totally unspecified order of compilation. Okay, so that's been the model that's in place the whole time. One or another variant of that model, and that's been sort of rearranged a few times. Now, oh, I wonder if this is messing with the eye tracker. Is it, can you guys still see the eye tracker with the mic in front of my face like this? I hope so. Is this working? Anyway. Now, it turns out the thing that I sort of understood, but not very clearly early on, is that you know, you have to be careful when you say that things are scheduled and they wait on each other in order to get their type inferred. You need to be careful about not over constraining that so that things deadlock, right? So for example, here's this entire procedure, right? And most of the things I need to infer are in the body of this procedure. But because it's a fully compiled language, right? The only things that matter if I want to call this procedure are things that are in the header here. right? So I just need to know the types of this. And then anyone else who needs to call this can know the return types, right? So these are the return types. So now anybody who calls find and occupy empty slot, well, we know what the return types are, and then those guys can infer, right? Now, if I force those guys to wait until the entire body is done, well, this body might depend on some other things that depend on those other procedures being compiled, right? And so you can end up in a situation where everybody's waiting on everybody else, even though it's a valid program. And you want to avoid that. And so to avoid that, I ended up with a system where procedures are sort of in that scheduler twice, right? This is the queuing system that you might have seen in earlier streams. They're in there once just for the header, and they're in there the second time for the body. Now, most things that are in the scheduler have one pointer to their queued structure, which is the thing that stores the information about how they're scheduled. But procedures have two because they're in there twice, and because then you need to know exactly what's happening, then that queued struct that holds the information has some special flags. So oh, they're not here. They're in general. They're in interp. So we've got some flags like, oh, if this queued has a lambda header or body, we set these flags on there, and some other people do ifs on those flags, right? So lambdas are more complicated than everything else in the system because everybody has to handle them being in there twice. And it's easy to be confused about if a lambda comes up in the scheduler. It's easy to be confused about whether you're supposed to be thinking about the body or the header. And so what I want to do today, and it may take longer than just today, but we're going to try to make this incremental so it's not too painful. I want to split lambda into two parts. I want to split it into an explicit lambda header and then lambda body that has a pointer to the header. And those will each have one entry in the scheduler. And then I can get rid of those weird flags. I can get rid of these things. Oh, the other thing that's confusing is, you know, if we go back and look at expression. So here, expression has, it has its own queued, and this is what most people use. But lambda uses these, except that header queued is also equal to this. And it's just like, it's confusing. It's more complexity than we would like, and I would like clarity around this. Now, the thing that's going to make this a painful refactor is just like, look, it's a compiler. It refers to procedures everywhere. So if we're going to change the way procedures are manipulated, even a little bit, it's going to touch a lot of code. I just got some T on my keyboard. Let me wipe that out. It's going to touch a lot of code. And to see at minimum how much code is concerned with this, we can just do a really quick project search for asked lambda. Not even case insensitive, I don't think, right? Oh, yeah. Okay, so this will match the enums as well as the struct names. Let's just see how many matches there are for this. Only 453. That's actually less than I thought, honestly. But if we rename this variable from lambda to either header or body, then a bunch of lines internal to the thing are going to have to change also. Anyway, any questions about that? Does anyone have questions about the big plan? I'm actually not using the Leopold keyboard anymore. I'm back to the Razer Black Widow Chroma or whatever. The Leopold, I think I got too much food in it and the keys didn't press very well anymore. Is a line count warranted? Yeah, let's do a line count. That's a good question. So we're at 41513. I'm going to write that down. I assume our number of lines is going to stay the same or go slightly up because most cleanups result in more lines. But it would be nice if it went down. This will probably not make the compiler faster. If anything, it might make it slightly slower, but probably not enough to matter. It's mostly to simplify the compiler in terms of being able to work on it, which is very important because robustness of the compiler depends very heavily right now on me being able to understand what the hell's going on. And if I don't understand what the hell's going on, like I wrote almost the whole compiler, so if I don't understand it, nobody else is going to understand it. So this is just one step of many. This by itself will not drastically reduce complexity of the compiler, but it's one of the many, many knots that are in there. And, you know, you untie the knots one at a time, and then eventually you've got something good. How do you say the value of this parameter must be using struct X, as you said you usually do with entities? Well, using doesn't affect the value. So you're going to have to clarify your question a little bit more. Do you mean that you want to take a parameter to a procedure and that parameter must be using another one? If you want to do that, actually that happens automatically because just like in C++, you automatically get a cast down to a base class. That happens here as well. So you can just automatically call a procedure that way. And if it takes the base class or a pointer to that, then you can call it with anyone derived like that. Does the line count ignore the single lines with braces? I'm not sure, but I don't think so. But my programming style, I don't tend to put a single brace on a line by itself, right? I tend to do this, or a single open brace. Closed braces, yeah, they tend to, you know, I don't know if that counts as a line or not. We can find out. Let's save that and count. 41512. How about if it's just closed brace? Okay, so it looks to me like any non-white space. Yeah, any non-white space counts as a line or non-comment, right? So if I add a bunch of comment, that shouldn't count, right? Yeah, didn't count. What about semicolons? Those count. Interesting. All right. Why don't I have two phases in the compiler? One where you do the interface and one for the actual compile. So you explicitly know in which phase of the compile you are and don't need two queues for lambdas. Well, you would have to tell me what you mean by for the interface. Because that's the actual hard part. Knowing the type of everything in your program is the hard part. You know, once you've got generics and all that. I mean, knowing the type of everything combined with, you know, out of order compilation is the hard part. Everything else, like once you know the types of things, generating code for those is very easy. It's actually the least complicated part of the compiler, probably. I mean, of course, optimizing that code is complicated, but we don't try to optimize right now. So, yeah, really this type checking phase that I'm talking about is the vast majority of the complexity of the compiler. And that's why I'm always looking for ways to make it simpler. Will the final line count be less than 50,000 lines? I have no idea. I mean, if you mean final, like by the time this stops being maintained, then I doubt it. But I'm going to keep it low for as long as I can. Do you know of any resources about out-of-order compilation? You have difficulties implementing it. I don't know of any, although I think maybe some other... I'm not sure if D is fully out of order, but it might be. So you might go to dlang.org and see what they say. I'm not sure about that, though. Rust might be out of order. It might not. I'm not sure. I don't know those languages well enough to know. When was the first time I started programming? When I was 10 years old, and I am now 46 years. Okay. Now, the question is, how do we do this in an incremental way? Well, I think the first thing I'm going to do is make a thing called lambda body. And I'm going to leave lambda called lambda right now, because if I rename this lambda header, all hell is going to break loose. I think it's my general impression that a lot more people, this may not be strictly true, but I think a lot more people care about the header than the body. So if we just keep this ask lambda for a while, and then once everything compiles, we rename it ask lambda header, that may be the route to least pain. So we're going to make a lambda body right now. It's not going to have anything in it. All the information is going to be in the header for now. Well, maybe this stuff. Oh, I don't actually know. Well, I mean, what's going to be in the body, honestly? Almost none of this information is going to be in the body. Like even this bytecode is not going to be in the body. So maybe block. Block is going to end up in the body. And even that may cause some pain. All this other stuff. Yeah. The body is going to have literally very little information for now. Maybe later, as concerns get more separated, it'll have more, right? And that might be one reason why I originally did it. I did this a few years ago now, but why I originally did it so that there was only one struct. I was like, well, there's not really that much to actually put in the body only. But we're going to see. Okay. This is going to be lambda body, and it's going to have this new enum called lambda body. And these enums get exported out to, I've got to write down, make sure program print can handle this. That's a user level library. But our tests will probably fail. Maybe they won't. Anyway, I wrote it down to remember. Okay, so where is lambda? It's like number 19, and there's not really anything near it. So we're going to use the first slot. They don't have to be consecutive. Okay, well, that should compile. Doesn't. Did I forget a semicolon or something? Oh, I'm mixing up my C++ and my new language. That's all. Double colon. Double colon. Lambda body shaming. By interface, you mean the procedures without their bodies. It might be possible to simply ignore the body on a phase of the compile. That's essentially what I'm doing, except it's not... It's not really as cleanly cut. Like, things go through phases of the compile like that, but they go individually. It's not like the whole program proceeds through phases. So I mean, I suppose you could do something like that, but there's not really any need. Okay. We've got a body now. Things compile. Nobody ever makes this body. So the main place, there's a routine called make lambda. And it gets called so many times. Now, our first challenge is that C++ only gives us frickin' one return value, and now we want two. We want to return a header and a body. The body points at the header, so we could return the body, but not everybody wants the body. But there's only, you know, there's only like 16 calling sites for this. So we could return the body and then switch to the header in the next line, which is going to add lines of code, but whatever. Okay, in order to facilitate, we're also going to have pointers between these. The body is going to point at the header. And the header is also going to point at the body, so we can get back and forth. But that's going to be temporary, so that maybe eventually we can have a thing that's just the header with no body. Maybe not. Who knows? All right. So make lambda lives in okay. So we make the header and the body, and we do all this stuff. We have q lambda. And right now is where it starts getting ugly, I think. We're just going to start we're just going to get rid of this flag. Let's get rid of it in the header file. That's the wrong header file again. So we're going to get rid of these two flags. All right. So we're inviting disaster right here. Oh, we're also going to get rid of header queued. Whoops. Header queued and body queued, those are gone. So now a lot of people are going to be unhappy, but hopefully it's a subset of everything, and then we can work from there. Okay, so what was I just looking at? Okay, so this right. Let's just do that now. Say interp q for resolve lambda file line. Because the reason we had to do this and not use the standard one is just that we were doing something special. But now the whole point is we're doing things more in line with the rest of the system. So okay. Now, and then these are dependencies between the two. So what we say is, the body has to wait on the header to infer or be sized or send messages. But then the header waits on the body when we're patching and running because, the caller, if you're trying to run code at compile time, the person who's calling only looks at the header. And so you don't want the header to say it's runnable until the body is runnable. There's probably other ways to do that. In the end, I want to get rid of all these depends because they're not the right way to do that. But okay. Okay. So do people even call Q lambda? I guess it's also called from copier. Oh, that's going to be interesting because now, we're going to be copying these things separately. Well, yeah, so the two things that we need to make sure know about lambda body, well, a lot of things eventually do, but for sure, copying and flattening both need to know about it because they need to know about everything. So when we copy a lambda, we've got to copy the body, and we need to say lambda body start lambda body. I guess we see header. These are just macros that, they just do these things. So there. Now, in here, when we flatten, eventually this might move, because this is all the statements in the body, right? So that might move into the body struct. But for now, recall our body struct is just empty, right? It just has a pointer to the header. So we're really using this for more clarity in the scheduler so far. And then maybe eventually some data will move in there. Okay, so similarly here, body, start lambda body, finish, C header. All right. Well, now we compile and we see a lot of places that are unhappy due to the things we removed. Oh, well, also Q lambda is not going to work. That's in copier. Well, I'm not really sure that's the right place to do that, but it's the equivalent of what was happening before. Body queued is not a member of ask lambda. Okay. All right. So that was in a header file, so it was blocking all this. But now we're compiling all these files. And because it's annoying to scroll to the top, the way I tend to do this for maximum goodness of working with Visual Studio is by attacking whatever file is on the bottom so that we just see it getting shorter. So that's typer.cpp. So we're just going to go in there and just start cleaning up references to these things. Why am I using this yellow cursor? Oh, it's an eye tracker, yes. Are you sure this has been covered ad nauseum? What type of Lexer parser? No, it is all hand rolled. No tools. No tools. Yeah, dude, everything about the interface in Visual Studio is terrible, and it gets worse every time. Like the breakpoint interface now, like sometime between 2015 and 2017, they broke it so bad. Or no, 2013 and 2017. They broke it so bad. Actually, I think it was in 2015 they made it bad. And in 2017, they made it truly awful. It's like the worst thing now. How would I make the world better if I were 24 today? By working on something to make the world better. It's hard to say because, you know, I mean, I make video games. Does that exactly make the world better? But I think it does a little bit. Not all video games, certainly. Like if you work at Facebook, you're probably making the world worse. But here, not so much. What am I using my double underscores to signify in file and line? Those are not my double underscores. Okay, these are C preprocessor things. That's why they have double underscores, so that they're clear that it's not part of your program and to not collide with your namespace. This says, hey, C preprocessor, insert the file name. And hey, C preprocessor, insert the line number. So this just tells me, for debugging purposes, what file and line queued this thing into the scheduler, because there's lots of places that queue things into the scheduler. And when I'm debugging the scheduler, I want to know how it got there. And this is how I do that. Any tips on game engine API design? That is a super broad question. You'd have to be more specific about what. Okay. Well, like I said, we're going to Typer. Let's just search for body queued. Find declaration helper. So here we can just say arrow body. So all lambdas have a body right now. That may not be true eventually, but it is true right now. I'm not sure how much to defensively. Let's not defensively do that. We're going to do the straightforward version of what we have now, which is everybody has a body. Even things that you wouldn't think have a body, like just the type declaration for a Lambda type or a foreign procedure whose body is defined in C somewhere else. We still have a body data structure for those. Okay. Well, I mean, I guess this is the right thing to do. Now, the reason this might be making things slightly slower, like I said before, is we're going through one more pointer here, right? But the lambda and the body were allocated sequentially, so they're right next to each other in memory, because it's not a random heap allocator, it's a sequential allocator. So like it should be in cache in all these cases. But you know, okay, well, let's relook at the lambda has a body. Yeah, that's right, I guess. Wow, I didn't realize. Also, you know, it looks like you're dereferencing this all the time, but the compiler probably optimizes that, and even if it doesn't, you could grab it into a local variable. So it's not as many dereferences in actual fact as I'm inserting. So the reason I'm doing these by hand instead of doing a blanket search and replace is just to force myself to at least look a little bit at the code, even if my eyes glaze over as they are right now. I want to at least there's some possibility that if something doesn't make sense anymore, that I will spot it. You know, which this is weird because all lambdas are queued right now, aren't they? Are queued currently. Okay, there were several times in compiler history when I toggled back and forth between lambdas being queued or not. Okay. All right. Get rid of this. This is really old. Is that? Yeah, it's still called. Okay, we're making constructors. Hey, okay, so now we're down to these in this file. Is lambda header, is lambda body, is lambda header. So this will be expression type is asked lambda. This is a header. See, here we have an assert that if that header flag was set, that that the type is lambda, and now we're just going by the type no matter what. Yeah. Okay. Is lambda body outer undeclared identifier? Did I delete? Shoot, we're going to have to look at a diff there. I deleted something. Around line 5321. No? Was it earlier? Where did outer come from? Oh, it was just get current. What line is this problem in? So confused. Visual Studio. What line? 5321. I knew that. Why do I have this old copy floating around? Stupid Windows noise. 5321. Outer. Yeah, it just came from the line before that. Right, because we didn't need to check it. So it's resolving outer arrow expression, arrow body, arrow queued. Okay. Oh. Okay, now we're down to is lambda bodies. Okay, queued expression type is asked lambda body. Actually, let's see that previous one that I did, if that had one of these asserts. No. Okay. So this is now a lambda body, and we're going to say body arrow header. Is that a polymorphic function? Then we skip the body. Okay. Whatevs, man. Body header, okay. Okay. hey, typer.cpp finished. Now, bytecoderunner.cpp. Or no, polymorph.cpp. This is referring to the declaration of the header file. All right. See, this is the great thing about statically typed languages, is they just tell you all your to-do list, right? Whereas the reason people are scared of refactoring in some of these web languages and why they think unit tests are critical and all that is because you can't do this kind of thing. The language isn't as robust. And so this kind of technique that I'm doing right now is not really doable in those languages, and it's really terrible. It's Maxwell Perlman. Okay, I am going to heat up some more tea. Are there any questions now about what's going on here? Any questions? Short recap on what's going on. We are refactoring the way that procedures are represented in the scheduler in order to make it clean and like the rest of the system and untie knots and weird if statements that happen. And we're trying to do that as incrementally as possible. Will the compiler ever be bootstrapped? Yes, probably eventually, but not for a long time. As a younger programmer, your streams feel way beyond my realm of understanding. That's fine, though. When I was a younger programmer, they would have felt beyond my understanding, too. It's just how it goes, right? So you just keep practicing, and you get better. And your realm of what you know how to do just gets bigger and bigger over time. Someone's asking, what's the scheduler? You can go back and watch the recording later on for this kind of, I can't spend all my time recapping because new people come in the channel all the time. So I can just say, it's the way the compiler decides what to compile. And if you want more information about that, we did a recap at the beginning of this stream after the pre-stream Q&A. Okay, our current tea, since people always ask what kind of tea it is. Our current tea is Clipper Organic Earl Grey tea that Casey got me for my birthday last year in Seattle. And then I moved back down here to San Francisco when I moved from Seattle. So any advice for dealing with analysis paralysis when deciding how to start implementing something? Yes. Here's the thing. When it comes to programming, if something is a complicated thing and you're having a hard time knowing how to implement it, the thing number one to realize is one of the reasons you're having a hard time implementing that thing is because you're not yet an expert at that task or at that kind of system, right? You could imagine a decade hence, after working hard on that system, you become an expert at it, and then that decision would be easy, right? You should be able to imagine that, because if you have any experience, you can remember a time when things were hard for you that aren't hard anymore, right? So if you were more of an expert at that kind of programming or that kind of task, you would make a better decision. Hold on, I got to turn the stupid teapot off. And so really your job is not necessarily to try to make the right decision. Your job is to get more expertise at that kind of thing so that you know that your decision will be correct. And the best way to get more expertise at making that decision is to just try something. Like, okay, I don't know which of these ways of doing it is going to be the best. I'm just going to do it one of those ways, and I'm going to see what's good about that and what's bad about that. And then if that turns out not to be the right way, I'll rewrite it later. And so some people think of rewriting things as like, oh no, I have to throw away all this work that I did, which is like, look, your goal should be to be a good enough programmer that you don't care if you throw away 5,000 lines of code that you wrote. In fact, you're happy that you threw away 5,000 lines of code that you wrote, because the next 3,000 that replaces that 5,000 are going to be way better, right? And your real measure of progress is how good you are at things, not how much kind of crappy software you put out that people begrudgingly run and have a hard time with, right? So experienced programmers, well, I won't make a blanket statement there, but I'll just say it really helps for your quality of output if you like making the things that you did better. And so I would say, it's not necessarily productive to analyze too much what you're going to do, because your analysis is naive. Because you're not an expert in that thing yet, unless you're doing something that you've done a million times, in which case you wouldn't need to analyze, right? So you're not an expert in that thing, so your analysis is not going to produce good results anyway. So just get better at it. And do something that you think is going to vaguely work. It doesn't matter if it's the best or not, because you're really building your experience. You were reading an OOP blog, and the writer suggested that using primitives was a code smell, and that something like age should be a class, so it's available to be filled with stuff. What are your thoughts on that? My thoughts is that that's the kind of bad programmer that has put software in the terrible place that it is today. That sounds absurd. I mean, obviously I can't see the actual example that this person was writing about, so I don't want to attempt to judge something that I'm not seeing. But it sounds like just all the sort of nonsense that was trendy in the 1980s that led to badness, 80s and 90s. How is my compiler so much faster than the C++ ones? Is it problems with the C++ ones, or is there a design decision you made that is much better? Okay, C++ has a fundamental problem, and that problem is header files. Okay, so the biggest factor in the speed of C++ is the presence of header files. Header files were originally an optimization, right? Because the idea was, well, we want to only do a single pass over our program text because that's simple and that'll be fast. And so you have to make sure that anything you're going to use is declared before it's used. And the way you do that in something like C++ is you organize it into a header, right? The problem is now that headers tend to be large and tend to be included many, many times. And now in C++, templates can only really effectively be in headers. And so like all your code starts migrating into headers and you start compiling code n squared number of times. It's, that's the number one problem. In C++, people know that. I mean, I told Bjarne Strostrup this in like 2002, and he sent me an email saying, you don't know how to program. Otherwise, all your programs would compile instantly. Turns out history has proved him wrong about that. And the C++ committee now is doing this modules thing to try to address that. But that's the number one problem in C++ compilation speed, but also C. Number two is complexity of the language. The more complex your language is, like C++, the slower it is going to be to compile because just the gnarlier the code has to be, right? So A, the code has to do all these complicated if statements all the time to check things. But B, the gnarlier the code is, the less people can really optimize, because to optimize things, you have to understand them very clearly and you have to be not afraid to make changes. And when you have to have the agility to make changes without those changes breaking things, right? And the gnarlier the things are, the less true all those things are. So the less effectively you can optimize, right? And part three is just that the people who are making compilers are more like mainstream programmers. And mainstream programmers long ago stopped being the kinds of people who even know how to write fast code, right? People think they know how to write fast code, but they don't. I've explained in several cases why object-oriented, or in several occasions, why object-oriented code is inherently slow. People don't seem to believe me. People seem to say things like, oh, it doesn't really matter whether your code is OO or not. You know, efficiency is about something else. No, it really isn't. Efficiency these days on modern computers is about how your data is organized. And object-orientedness presumes that data is organized along a certain kind of abstraction that puts it into small chunks far away from each other. And that is very, very, very bad for performance. It's also very bad for other things like volume of code, just number of lines of code. It's bad for understanding your program. But that's the way that these people have been taught. By these people, I just mean mainstream programmers, have been taught is the right way to program, and they will dogmatically defend it and so forth, right? And so the kinds of design decisions that are being made in these compilers are that kind of a thing, and they're antithetical to making software that actually runs fast. So all of that taken together, plus some other things, is reasons why current compilers for those languages are slow. Does throwing away lines of code count as negative lines of code for the industry average? Yes. Yes, it does, but you should be proud of that. You've heard that thing about primitives being code smell. The idea for age, for example, is you want to prevent negative ages, etc. So say assert age is greater than or equal to 0. Done. What's the problem? Header files were also an API for the user. You could implement stubs and go ahead and write code while waiting for the complete and correct solution. That is true. That was a good thing about header files, but you can also do that without header files. Like your stub can just be, you know, this, and then the body is just assert false, so that if anyone tries to call it, it's like, oh, it's not done yet, right? But you know, it's true. It's true that header files used to be more like a concise summary of what the actual C file contained, but they're really, in C++, they are really not that at all anymore. So yeah. Have I seen the brand new Razer Blade? Lol, isn't the laptop market depressing? Yeah, I assumed I was going to buy a Razer Blade when they announced it, and I didn't. I bought an Alienware, sadly. It has not yet been delivered. It should get here any day. What would I advise someone that wants to write cleaner and better code? Notice what's hard to understand about your program and try to make it easier to understand, whatever that is. If someone's telling you to program in an object-oriented way and you have all these class hierarchies and it's hard to understand how they interact with each other, then try to make that simpler, right? If you're writing in a procedural way and you know you have all these things that are mutating some number of values with a bunch of if statements that are hard to follow, just try to make that simpler. Just try to simplify. It's the simpler, the better. Why don't I use C? Because C++ has some features that I actually want. For example, you know, auto is a good feature. I do use single inheritance in C++ in a very limited fashion. You know, there's just, C++ has some features that you really want. It's just that it's gone crazy and bananas. I think Casey uses C though, doesn't he? Or no, Casey probably uses C++. Sean probably uses C. Sean Barrett. Someone's saying, my understanding of why OO is bad is because it structures things in AOS rather than SOA. That's not strictly true. That is one detail of what's bad, but the real problem is that object-oriented programming conflates data ownership with functionality. Whereas you really want to have, or like, it conflates the concept of something with who owns the data, right? Object-oriented programming says the object owns the data. And that's wrong. Fast programs don't let the object own the data. So, yeah. So AOS versus being able to put things in SOA is one instance of being able to own the data, but that's not the only one by any means, not remotely. Like, for example, just being in full control of memory allocation means that if that object allocates sub things, well, maybe you don't want the object to allocate sub things, or maybe you want to allocate it and give the object the memory and have it know what to do with that memory and so forth, right? So this idea that there's this abstraction boundary around the object that acts like the boundary of a sovereign nation, and that you have no right to know what goes on inside there, and that anything could happen in there. That is how you make slow programs. Yeah. The question of when you want SOA versus AOS is, it's complicated, and it's actually a little bit of a different question. How did we get the models for Sokoban? We have people who do those things. Yeah, operator overloading I also use. So, Okay, let's get back to the actual work here. Let's stop slacking with the questions. This header is for structs. We want to clean that up eventually too. That's a much simpler cleanup, but it's not that important. Okay. Well, now let's see what it complains about. Oh, many fewer things. So body queued is not a member of Ask Lambda. Body queued. So we're just going to say that. Okay. Are we done with that file? Yeah. Okay, we're on to pipes.cpp. Is lambda body. Okay. Here's one of those cases where it used to be ambiguous. We're saying what is the expression of this thing? If it's a lambda, well, if it's a header, right? So now all asked lambda are headers. A body would be asked lambda body. So we can get rid of this if statement right here. And we don't have to assert that the type is asked lambda. That's ridiculous. Okay. So that's a very simple one of the kinds of knots that we're trying to untie. There are gnarlier ones. So again, if we get a lambda, okay. So we're building bytecode. Okay, so bytecode builder, we're just going to pass the header there for now, so that we don't have to change that. We're just going to leave this all called lambda. Okay, if we have an expression in the declaration and it's a lambda, and the body is not through build, then we have incomplete uses. Okay, yeah, great. Great. Okay, 1299. Well, if the expression type is lambda, then it's header, otherwise it's body. So what do we do here? Emit code. Oh, this is when things get to pipe output C, where it's not really outputting to C anymore. It's like outputting to whatever backend. We should rename that. So this is a place where maybe we could use a little more clarity. I mean, it almost seems like we could accidentally do this twice. Once for the header and once for the body. Okay, we're going to say, this might break something, but we're going to say, if it's a body, right, okay. Oh, wait. What? I see. Okay, we actually pass is body down here. So maybe I'm doing the wrong thing. Let me just look at... Oh, it's is header return. Okay, whatever. This obviously used to be more complicated. So we're going to get rid of all that. Is body is trivially true. Okay. Same thing here. Oh! He actually uses that? I'm going to assume... What does get procedure name do? We init the C conversion name. Which we may need to do. We may need to do. Okay. We'll just do that for LLVM, whatever. Because it's C++, we have to edit the header files here. Okay, and then back in pipes, okay. So here, Okay. So if it's a lambda or a lambda body, well, so we assign this thing lambda to be the header, and we get rid of these. Okay. Something like that. Okay, that file is done. I didn't even compile it? What? Yeah, okay. Parser. Relatively rote replacement here. Header queued. I hope I'm not just massively screwing something up by not thinking about these. Messenger. Okay, this is going to be redundant. So, oh yeah, okay. We need to get rid of all this stuff too. So this is when we export things to external programs. Like you can have a message loop in your program, like your meta program is looking at what gets compiled. And that was another reason I wanted to do this, was that was confusing too, because people had to look and like ignore headers if they only wanted to search the bodies and whatever, and it was confusing about what's a header or not. So here we can get rid of that, and just the value will either be a header or a body. So yeah, let's get rid of this. Let's get rid of this. We don't need that, so that's going to complain. Okay. So we're going to get rid of is procedure header and procedure body. And we have to get rid of that in, where is that? That's down here. Get rid of those. And we're just making more problems for ourselves, but that's our job today, is to make problems and then solve them. Okay, so let's continue with Messenger, and then eventually we'll have to confront the new problems we just made. All right. Interp.cpp. See what's going on in chat. Can you get a hip and toe tracker? If you can link me on the internet to someplace where I can get hip and toe trackers. Why do you use auto? It seems to me if you know the type that an expression evaluates to, you just write the type, not auto. Sometimes so it makes refactoring easier. So if you change the type of something, then you don't have to change all these redundant statements. And sometimes it's just too much typing and it discourages you from having readable type names. So in C, if you wanted to malloc something, you would end up writing the type 3 times. You'd say type, long type name star X equals cast to long type name star malloc open paren size of long type name close paren. It's ridiculous, right? And so, you know, auto is to help with things like that as well. So Miracine says, oh, this is about the SOA versus AOS. And I was saying that's not the root point. And they're saying it's a problem with keeping things retained versus immediate, i.e. the memory is controlled by the interface. I don't know if retained versus immediate is exactly the way, I mean, that's related, but it's different as well. It's just about whether you conceptualize something as it's about how strong the boundaries are around things, right? If the boundary's too strong, then there's just a lot that you can't do in practice, right? And part of what you because the speed of a modern program depends so much on memory, then memory is one of the things that you really should care about. And yet in these conceptualizations of object-oriented programming, the idea is that the thing owns its own memory, which does not give the main program the ability to do anything there, right? But even if your thing isn't like privately allocating resources, if whatever class that is, you know, like if something is an object, you can't necessarily copy it around trivially without knowing what's going to happen, right? Whereas if something is data, then you can. So it's about that. You don't need to cast in C. Yeah, you do. Older C, you didn't need to, but newer C, you do. Ever since, I don't know. Maybe they fixed that again, but for a while you had to cast. Ideally, would you allocate no memory at runtime? I say that because the thing is, sometimes the job you're doing involves dynamic allocation of memory. So you absolutely do need to allocate memory at runtime sometimes. It's more like, ideally, you wouldn't allocate memory if you don't have to. Yeah, maybe C11 fixed that. I don't know. I haven't programmed in C in a long time. Okay, let's continue. Yeah, C++, though, by the way, made the wrong choice about void star. They said, oh, you have to explicitly cast void star to anything. And that's exactly wrong, because if something is void star, the reason you made it that is because you want it to cast to things. So now you're forcing people to insert noisy casts, when really, which then means you can't know, it decreases your ability to know when an actual scary cast that might be a bug is really there, you know? So yeah, it was the wrong choice for C++. Opening my window. So in this language, for example, void star silently implicitly casts. Oh, that's a little too bright. Okay, hold on. Hold on. Okay, better. We got some light coming in from the outdoors, but it's nothing crazy. Any recommended reading for someone going back to school for computer science? No, not really. Sorry. Well, can't you just write malloc t of whatever to avoid casting? I don't know. Dude, anything with templates in C++ I just ignore, okay? So I don't know what they do now. I use auto, that's what I do. Okay. Well, interp.cpp 2427. We've got a lambda. The load directive. Okay, this is when we get a body text. In principle, maybe later this should be lambda body directly. In fact, let's do that. So we're going to have to go make sure. So body. What is target lambda? Okay. Right. So we will go there. So now we have to make sure that when we set target expression, it's set to the body. It's simple enough. Oh, but we've got to go to the declaration of target expression. Oh, right, that's not just lambdas, it's anything, so that's fine. Okay, interp 2980. Okay. Lambda equals make lambda. Lambda name, lambda flags, depend. Sure, seems reasonable. Oh, we're done with that file. Copier. I thought we did that. Did we just not do the prototype? Yeah, we didn't do the prototype. All right. Whoa, there's really not that many compile errors left. We may soon be close to the time when we get to run it and watch it crash because I did something horribly wrong. Okay, 1564. Okay, stalled on Lambda. That should probably be a body, but we'll simplify that later. Like some of these weird knots that are slightly wrong can come out naturally over time later. Like if that really should be the body, that'll be something that I observe later and can do. Wait, what? I totally 5468. Typed in the wrong number. Yeah, like this probably should be a body being passed in. So this type is only used in this scope. Well, right now we store the bytecode on the header. So that's fine. We won't change that to the body yet. Okay. Okay. So if the constructor is not ready to run, is what that's about. I don't think we need get comment anymore. So yeah, I think okay. Get debug name. Oh. Never mind, because we're pulling the lambda off the name. For the name off the lambda. Okay, so we are going to bring this comment back. Wait, that was commented out, wasn't it? No. Wait, yes. Yes, it was. Okay. Okay, so you got to fix get comment. Whoops, there is no ask lambda header. It's just ask lambda right now. Oh. Implicit procedure made to evaluate the condition of if. We don't do that anymore. None of that. Okay, so this is going to split now. This is body. So here, well, it's not a body. So we're down to that. Oh, wait. Yeah. Okay. Oh. Here again, this would be redundant with that, so we just delete this. Boom. Oh, this is wrong. This is going to be wrong. You know, this is the kind of thing. So what this is saying is like, hey, is that expression matching mine? Which assumes that the entries for the lambda, if we crash, I'm going to make a note. This is like, hey, if those two expressions are the same, which they're not the same anymore, even though they point to the same procedure. Good thing I at least was paying a little bit of attention, but I bet I skipped over another one of these. So I'm going to say auto body is static, cast as lambda body depth target queued expression if body header is equal to node queued expression. All right. Well, it looks like we compile. Because I don't trust dependency management in this compiler, well, and let's just go to debug build anyway, because like it's probably not going to work. Let's be honest. Let's be honest. Hey, look, it didn't. There's probably some assertions that don't compile. If I sit too high up, I'm out of eye tracker range. So I don't know. I have to slouch a little bit. I guess. Okay. Now what? Well, now we watch this die horribly. Yep. But actually, that's not that bad. What this means is like, hey, you forgot to handle body in Messenger somewhere, which is not that bad of a problem. Right? So, yeah, so in Messenger, remember what I said about like people not knowing if something was a header or a body or what? Like now you would know, except that you don't know because we don't tell you. So we need to, and here what we're saying is, look, if we're sending a body through the messenger, we should have already sent the header. So because it's the same pointer, our exported pointer should be there. But that's not really what should happen, right? So what should happen is we should have another case here. So I'm going to take a short snack break and make a new T, queue up whatever questions you have, and then we'll fix this and see what the next crash is. So any questions? All right, we are back on the Bengal Spice now. How do you decide it's time to do a refactor like this? Well, it's just kind of when I feel like it. When I no longer feel like it's critical to do other things first. You know, sometimes, like, it wasn't absolutely that important for me to do this, but I want to do it eventually. And sometimes when you do something like this that you've been thinking about for a while, you just get it off your mental backlog and you create more space to think about new things. I don't know. You just do, I'm having fun programming in life, so I do the things that I want to do. When you call delete, how does it know how much memory to free? Where is that information stored? So it's the same. You don't worry about the array version of delete. It's the same answer as if you allocate a single struct, how does it know how much memory to free when you free the struct? Or if you allocate 1,017 bytes that aren't typed in any way, except that it's 1,017 bytes, how does it know how much to free when you free that pointer, right? And the answer is the allocator stores the size of the block in all those cases. How do you motivate yourself to go through some big change of your program which you know is going to be nasty? Well, because I like things that are not nasty, and I think about how nice it will be when that is done. But you can also think about, so there's a reason why you want to do that change, right? You want to do that change because there's something undesirable about the way things currently work. And that is causing problems for you. Maybe they're just low-grade problems. Maybe they're high-grade problems, like the compiler doesn't work on everything or whatever. So you can think about, if you never make that change, then add up, integrate over time for all the future years that you would be writing this software or using it, how much that inconvenience is going to cost you, and you add up all those little bits over all that time, and it's quite substantial. And so why not do the shorter term unpleasant thing and rip the Band-Aid off and just make it better? And then you don't have to suffer all that longer term problem. Best way to go about storing a uint larger than a long, long unsigned int. An array of long, long unsigned ints. What is messenger.cpp about? What are the messages? The messages are the things that we send to your metaprogram when you're compiling or introspecting your own program that tell you about what's in the program. There are some whole streams that cover that on YouTube somewhere. What do I use to build my CPP code? Just standard MS build? Yes, unfortunately, but it is what it is. Any thoughts about GDPR? No. Okay. Let's do some more things. Let's fix this. So we got to go to Messenger. And before we edit that code, we've got to go to code procedure. So a lambda gets turned into code procedure. And so now we need to say struct code procedure body. Here we are going to call it header and body. And we use, for exporting to the people, we use the same stamps as we use internally, just for simplicity. It also makes things a little faster because you don't have to remap all the numbers. But at some point, this API has to freeze, and then that'll drift from the internals, and there'll have to be more remapping. So here, right now, we're going to do the same thing, where we link back and forth to both. And it's just, you may not have a body yet. And then eventually we'll migrate some stuff down into here. But for now, we're doing the minimal number of changes. Now we have to go. This is the user-facing thing. We're going to call this header. And whoever breaks because of that breaks, and we need to fix that. So body is also a struct. We do this. We do this. Okay. So now we go to here and we make, look at all this stuff. Well, let's carve the stuff out. So if we get here, we are definitely a header. So that just gets indented out, and this goes down. Oh, wait, what? Result is okay. So whatever we exported is a, oh, wait, no. That's not true anymore because it's not the same pointer anymore. So we have to export. I think we should only get here once, but who knows? Why don't I do this? Okay. Oh, right. We already set the types block and then resubmitted the Lambda. If we go to a more general code modification scheme where you don't retain type reservations. Oh, whatever. That, I so don't care about that now. Okay. Why am I doing that? What? I don't understand why the constants block is in the body. What? I don't think that's good. I don't think that's good at all, bro. I think that should be up here. Like, it's basically everything's in the header. Okay. So again, we have an is header versus is body. You know, okay. So let's be a little. Okay. We're going to put the block on the body and not the header. Whatever. Not necessary. Okay, I feel like the modify directives are probably not ready until the body. That's why we're doing this. Okay. This we may want to rearrange later, but hey, it is what it is. So, yeah, okay. Well, okay. I had said that I was going to put this block in the body. So we have to actually do that. And we have to set these pointers, which we're not doing yet. Whoops, not that. Block. That's all that finish does. It's not a very interesting macro. I'm not going to answer an OpenGL question right now. Okay. Maybe someone else in chat can answer the question. How are we doing for lines of code, by the way? We're 10 lines higher. That's not bad. Not bad. We were at 41513. That's the number I wrote down. And now we're at 41523. Okay, this check here was only for the thing about header and body both being lambda. So my theory is we could just do this. And then we don't have to have this check here. Now we're even one line lower. Yeah, okay. Okay, we need to set those header and body pointers back and forth. I'm going to turn down my desktop volume so that you guys don't get clobbered by that. All right, what did I screw up now? Parenthesis in the header file. Oh. Not really a parenthesis. Source exp. Oh. It's not source exp. Source is casted to lambda body. Source exp is just expression. Wow, look at all these errors, man. What? Code node to code. Really? Oh, because there is no code procedure. Thanks, C++. Wait, I just changed that. What are you? Oh, directive run. Okay. There's a forward declaration. There must be a forward declaration for code procedure. Yep. So let's just get this out of the way. Okay. Now we got to go back to here. Okay. Dude, I thought I did that. Right. Okay, we'll table that one for a second. Let's get rid of all these low-hanging fruit ones. Okay. Let's think about this. When we're importing, yeah. So all that separating that we did for Lambda was for export. We now have an import as well. So we want to import the body, and this is going to be in the body. And I guess everything else is in the header. Fudge. So we have a little bit of a counting issue. We're going to import the body. You see how Emacs just stalled there? Garbage collected editor. We currently depend on the fact that nobody outside can have a pointer directly to a body. So the header imports us, then sets the pointer to the header and so forth. Seems like it could be more robust. Okay. Well, so we do all this header stuff. We import the body. Then we set that. Because we need those pointers pointing back in both directions. Do I need to do anything else there? I don't know. Oh, well, I need this. I copied this before, and then I didn't. Oh, because, right. Oh, fudge. So the problem here The problem here is that our make lambda, which is what we started this session by changing. Well, first we started by changing the header file, then we did make lambda. This thing allocates the header and the body and points them at each other. Oh, so I don't need to point these at each other. Right. But the problem is, yeah, okay, you know what? Since nobody can have pointers in, we're just not going to do this way. We're just going to import the body right here. So this is all for when people do code modification, right? We give them the syntax tree, they can mess around with the syntax tree, and then they hand it back to us. So that's what we're dealing with here. Result arrow block. That's right. Source body block. And we don't actually need to set that pointer. Okay, who the hell knows what's going on? I certainly don't. I certainly don't, but we compile again, which may mean it's time for me to take a break soon. I don't know how the hell Shroud streams for 12 hours straight, but, you know. Unknown expression type in inference 6. So I assume, oh. Yeah, we haven't done the type inference part. So here we're inferring the header. What should we say is the type of the body? If we're inferring the body, yeah, this is a little dicey. This is where things get a little scary. Okay, case as lambda body. Yeah, I think. Okay. Something like that is happening. Okay. That's probably also, yeah, so type table. Okay, I'm gonna pause here because it's break time for me. It's time to walk to the store and get some chocolate. And then when we come back, we will, let me close my old window. When we come back, we will start attacking. Oh, we went a number of lines up. But it's okay. It's for a good cause. We're 18 lines up right now. Yeah. This is, so the type table is kind of like part of the messaging system, but it's also not for messaging. This is the thing that makes the type infos for people, which is how you introspect on types in the system. And something doesn't have a type, I assume that's a procedure body, and it's probably for a simple reason. The gnarly problems that were introduced by subtleties of all this, we haven't even hit yet. So yeah. Any last questions for on-topic questions before we take a break? In Scala, the type of a body is the type of the return value since it's expression based. Wouldn't that also work here? Well, so the thing is, you can't ever refer to a body explicitly. So when I say what should the type of it be, it's just for oh, dude, I didn't set the type here. I'm going to set it to void. Right. That's probably what was causing that error. So it could be anything. It doesn't matter. At least I think right now it doesn't matter. No, that didn't fix that problem. Okay. We can explicitly say expression here just in case. Anyway. Can I acknowledge your existence? No, I cannot. Are we still using the C-link or unfortunately yes? All right, I'm going on break. I'll see you guys when I get back in a little while. Break, break, break. Are there any advantages to writing the compiler in new languages? Yeah, there would be some, but the language isn't stabilized yet. And so that would be annoying to deal with. And then there's all sorts of disadvantages due to that, like adding friction to your development path and stuff. I'd just rather not do it that way. See you guys later.